Hello, everyone. Once again, hello from my side. I will be the moderator and the host of today's track, Business Application of Data Science and AI. I'm very happy to be here, and I'm very happy to announce our first speaker for today, and that will be Alexei Chernobrovov, who will deliver us a wonderful talk about using uplifting modeling based on decision trees for dynamic pricing. Basically, this report focuses on one of the approaches for solving the task of dynamic pricing for the internet shop. And basically, there's two groups of features that are being used for building the algorithm of dynamic pricing: data on users and data on goods. Algorithm is based on the iterative price change for clusters for goods. Another feature of the algorithm is the validation of the evaluation of the profit function at each step as an uplift modeling. In this report, Alexei will consider the example of the internet shop with the amount of more than 70,000 goods and more than 1 million unique users per month. Alexei holds PhD in maths, and he is a teacher and mentor of Netology. He has worked with some of well-known companies in Russia and CIS, and he's a member of expert of council of the Runet Prize. So I'll not take any more of your time. I will let Alexei to have a floor and to start with his presentation.
Hello everyone, my name is Alexei Chernobrovov, and I'm glad to participate in this conference. Today, we are talking about application of uplift modeling to dynamic pricing. As I said, I'm Alexei Chernobrovov, and a few words about me. I have PhD in math. I have been working with a number of large companies on Russian market on issues of data monetization, usage of dynamic pricing. Here in slide, you can see some of my clients. Mazda is one of the world's biggest car makers. Decathlon, sure you all know, the largest sporting goods retailer worldwide. Mars is a multinational manufacturer of confectionery, pet foods, and other food products. And other of my clients. And finally, I'm one of the 500 experts who decided which website and online project will be best considered in Russian segment of internet. Here on slide, you see link on my website where you can read different articles and watch videos on related topics. Let me show you our plan, what we are going to talk about. First, we talk about uplift modeling. When we discuss a dynamic pricing. And after when, we will try to apply ideas of uplift to dynamic pricing. And in the end, we will make some conclusions. What is uplift modeling? Classical approach to uplift modeling consists in the following. Let's imagine we are having a model that predicts sales after any treatment. Also, it predicts sales without any treatment. So uplift is the difference between those two actions. This model is often opposite to a traditional model that measures only the outcomes of any treatment. For example, sales probability after any treatment. Such opposition is needed to show that uplift models not only predict outcomes, but also serve to maximize the incremental return. In a classical uplift modeling, we can have four scenarios. In the first scenario, if we treat a customer and as a result of this impact, a customer makes a purchase, then the action is considered a good one. Also, we can have customers who will make a purchase without any treatment. And there are customers who will not buy if not treated. And the last fourth scenario, we have so-called sleeping dogs for customer whom better not to describe. They will unsubscribe or stop using our service, or any other negative action is possible even in case of a treatment. Uplift modeling is used to solve tasks of customer communication. It serves to improve technique of churn prediction. To come closer
to a concept of uplift modeling, we need to keep in the mind to solve given task using this approach. We need to use a tool of decision tree. Decision tree is good enough to solve task of uplift modeling. The main idea of decision tree is to increase distance divergence between distribution in control and treatment groups. Thus, task of uplift modeling can be reduced to a task of building of a decision tree. At every step, we perform an action, when we call it mini A/B test, where we divided a group into two parts on a base of attribute. And then we divided our sample into two groups. The first group is treated and the second remains without treatment, control. Further, we measure uplift and build a tree in depth. The authors of this approach managed to solve a task in a more general way. The approach is oriented to solve multi-class problem, and this approach can be used even if control group is empty. More details are in this article that is given here on the slide. Now, let's talk about dynamic pricing. The sense of dynamic pricing is that it can be formalized in different ways. In other words, it can have different objectives. In general, we have a certain price vector that can be managed in the time. So we have price vector x and profit function y, which depended on price. Also, function depended on time and uncertainty. For example, a task to find optimal price by a certain time, that means we are limited by a terminal time t. Second approach assumes that we need to find optimal price for a minimal time. Third approach assumes that we need to find an optimal sequence along which we'll manage price. Here the task is to get maximal profit along the entry time. And the four objectives, we need to find how y depended on x. Despite all these objectives are similar, they have absolutely different economical sense. Independence of that goal, a company achieves with time, we need to choose the right approach. For example, if a company at present does not have many customers, but it knows that by the moment t, the quantity of customers will be increased, that is responsible to choose the first one. Alternatively, in case a company has many customers and already reveal actions sales activity, that is a need to define an optimal price in minimal way. The third objective is the most difficult, since to find an optimal path is not so easy. The third objective often provides redundant information, as we don't need to know absolutely function dependence y on x. Within this presentation, we will talk about objective 1. So we need to keep in the mind that all these objectives are correlated. Dynamic pricing has several approaches how to solve this task. I would like to consider a basic one: parametric approach, Bayesian approach, and non-parametric models. You can see link to related works on this slide. Parametric approach implies the following concept. We have a profit function, for example. It is shown here on this slide. Profit y depends on demand or purchase probability, and multiplied by noise, a kind of uncertainty, and multiplied by price minus costs. So we say that our purchase probability is a function dependence on price, and it can be
linear, and decreasing. Of course, this function is not increasing since dependence between price and purchase probability is inverse. When we describe a function of linear approximation and further we define parameters. In this case, we are given parameters a and b, and in this way we optimize it. When we use a parametric approach, we try to find a function for each product, and for this we have a sample, and in case information is not enough. For example, price have never been changed before. We have to increase prices and increase numbers of samples for each product P on T. There are some disadvantages of this approach. It often happens that when we manage to find optimum for product with index I, it can change, but we cannot catch it. And every iteration we try to come closer to optimum. In some time, demand curve can change significantly. However, the model cannot catch changes and consider the status as optimal. Other disadvantages of this model is that is considered all goods and independent and defined them separately. But in really goods are independent on each other, and local optimum does not guarantee to a global optimum for all companies, for all goods. Bayesian approach used the following idea. It assumes that a company for each product can choose what action to make, to increase price or to decrease. Iterativity, it defined an optimal price. In general, this approach can find a global optimum, but it doesn't plot function y on x. In real life, it takes too much time. Non-parametric models is similar to Bayesian approach, and it uses multi-armed bandit. Each arm corresponds to a posted price. That means that each arm controls a certain price. This approach is more efficient than the previous, however, it also does not build a pricing model. It only offers iterative way to define the price. Thus, we are coming to application uplift modeling to dynamic pricing. Here, everything is as simple as to draw a node. Just take uplift modeling, take a dynamic pricing task, and apply uplift modeling to dynamic pricing. It's really simple. Our main objective is to plot function curve dependence model y on x, EA profit on price near global optimum price. To solve this task, we are going to use the concept of uplift modeling for dynamic pricing. Within this approach, for each product, we have three actions to choose between: to increase price, to decrease, or not to change at all. Thus, we develop a matrix where we see 9 possible outcomes. They are shown on this slide. Good outcomes happen in case we increase the price and it was needed to increase. When we do not change a price and product was in optimal status. And when we decrease the price, when it was needed to decrease. Also, we have various errors. According to the main idea of this algorithm, we need to build a decision tree and to divide goods into 3 groups. Group where we need to increase the price, group where we need to decrease the price, and the last one requires to no changes. No changes will be used as a control group. Since dynamic pricing has some specifications we cannot apply uplift modeling in direct. At every step, we need to collect information and find out customers' reaction. As a result, our decision tree shall come to certain status when all our goods are in group not to change. It means that we have reached a global optimum for all goods. In reality, it is difficult because there are lots of external factors that have impact on the curve and model always adopts. It is recommended to use binary trees since they are easy to build and it's allowed to avoid rewriting tools. Classical tools imply work with binary trees. Thus, each tree node may have following diversions. First option is other in increase price or not changes. And the second option is either to decrease price or not to change. It works for those goods which are defined as being in local optimum. Let's consider an example what we already had in classic uplift modeling. There are three groups: P with index inc, increase price; P with index dec, decrease price; P with index C, not changes, or our control group. We split by attribute Z and get two nodes. On the left, we get a positive uplift. On the right, negative. It means that we should not have increased the price, but to decrease. That's why at next step, we need to replace this node with the wet one, which instruct to decrease the price as a way of impacting. In this way, we build a tree in depth and nodes which shall be replaced at the next iterate. Our important thing that task is not static. We need to keep in the mind that if we're beginning or at moment of 0, we can do decision that price on this product group shall be increased. It doesn't mean that every time at each next iteration we need to follow this pattern, because further this product fall into a group that is defined as either to increase price or not changes. It is essential moment because when we rebuild our tree and make probing, that we need to remember what is last time we increased price and it was a correct decision, that we can divide products to a group where a price is decreased. This is possibility for additional optimization while trees building. Also, we can divide goods between control and treatment groups by random. Goods where reveal bad sales require any price decreasing. That is quite obvious. No need to say that price increase on such goods will not improve purchase probability. Also, I want to add that we always have a bottom price, below which can sell goods. Each product has cost price, and in case gap between cost price and sale price is little, we cannot decrease the price on these products as well. Two outcomes are possibility in here, either not to change or to increase, of course. Every probing costs some money, and we can not just test goods playing with price and sending them to any of groups. At first, it's recommended to build a pre-trained tree within already known data that are already available from previous commercial activities, if it's possible. If not possible, we may come to a classical probing. the last point to mention, it is absolutely practical. It serves to make process more convenient. When we build a decision tree, it's better to operate margin, but not price. In case of wide range of prices, we can also operate log margin. You can see some formulas on this slide. So we have discussed all particulars needed for this algorithm execution. First, we build our pretrain tree, carry out probing, and measure uplift. Now we fix a probing size. Normally, business requires a certain price range, and we can just take any prices we want. On practice, it's about 10 or 20%. After that, we set prices and measure the uplift. And after that, we repeated our 4 steps. Probing size we can also decrease on each iteration. That's all. Time to conclusions. This approach allows to use a slight change of price to each iterate. It is convenient for both customers and business. It allows us to operate margin 1 or 3%, for example. Also, we may regulate probing size, i.e. quantity of goods on which will we change price or keep without changing in control group. Algorithm always adopt, i.e. uplift is measured all the time, and goods from class not changes transferred to our if uplift is more than 0, because we use probing at each iteration. This approach allows to find a global optimum. And finally, it's easy to apply this method for multi-class cases. This approach does not require significant price changing. It can be applied for more classes. For example, when we talk about different levels of pricing, to increase significantly, a little bit, not change, and to decrease price a little bit and significantly. Also, algorithm builds a model that shows how to manage price and can be used for goods that show bad sales, fast start, goods with low demand. Tools are standard and it is easy to code. You can use a standard library. Thank you for your attention.